goodness. So part of being in a math class, being a good math student, is understanding when I always need to see work, but when you see something like this problem, all right, hold on, this problem, like this problem, or this problem, can you do those by hand? Can you? Yes. Do you think I want you to? Like the most you could do right here is add 1 and 0.05. And what's the next thing you should do with this problem? What's the next thing you should do?
Exponents.
True, but all right. I really want this. So what if I had this problem here? 5 times 6 minus 4 squared. All right, what would you do first in this problem here? What would you do first? Anyway, what would I do first in this problem?
6 minus 4.
6 minus 4, I love it. So this would be 5 times 2 squared. What would you do next?
2 times 2 is 4.
Yeah, see how simple that was? Wasn't that simple? I don't even have to write it down. 5 times 4, that's 20, yay. Now, if I have 2,000, so I'm back down here. If I have 2,000 times 1.05 to the 12th power, does anyone actually believe that I want you to do that by hand?
No.
Okay, I really
Calculator.
want you guys to fully understand. You must always show me work. You have shown, when you do this step right here, you have shown work. Now you throw it in the calculator. This problem has to be self-evident that you could do it all the way to the end. You should not need the calculator for that problem, and it should be self-evident. This problem, I don't mean write this 12 times and multiply it. Oh my God, right? And I don't want you to round. You should not round at all. So what the hell am I supposed to do with this problem? Throw the whole thing in the calculator so you get the correct final answer. Way too many people are telling me this is 2,000 times 1.79. This doesn't even round to 1.79. So don't do it in steps. What's the deal? If you're doing this in the calculator already, just do the whole thing in the calculator. Does that make sense? Is everybody with me? Anybody not with me? Let me see it like that. You guys all right out there? Trust me, I understand. I'm such a big stickler about showing work. I understand. But there will be problems like B and C that are very obviously not meant to do much by hand. That would be insane. Okay, maybe. So those you could basically just throw them right in the old calculator. No worries. Is that all right? You guys all right out there? What's going on, guys? You guys all right? Did everybody survive the weekend? What's going on?
Yes, everything fine.
Huh?
Yes, everything fine.
I'm sorry?
Yes, everything fine.
Oh, everything's fine. Okay.
Yeah.
I think I just haven't heard that phrase in so long. It was foreign to me. Everything's fine. What? All right. Anything else, guys, from any homework or from the quiz? Quizzes are graded, so take a look. The average was a 76, if I remember correctly. Yes, average was a 76.7. That's important. 76.7. Which I don't know how you guys feel about that. That's actually a good average. The funny thing is, if you take statistics, in fact, in this class later this semester, we're going to learn one more number to calculate. Stay with me now. In the section we just did with the mean, median, mode, that section, we've already seen how there's issues with the number that represents the middle of the data, right? Like the one set where the guy had a 0 and it threw everything off. Although I love some of you guys. Some of you guys are primed to be an evil teacher. You're all like, I think the teacher was right. They all suck. I'm like, damn. But there's one other number, and I see your question, Raji. I'll get it. There's one other number we're gonna start to talk about a little bit in this class, and then you're gonna really study it in statistics if you take statistics. That tells you how spread out the data is. And I haven't calculated that number yet for our quiz, but I'd be curious to see how spread out the grades were. Right? I don't think anybody did like crazy bad, thankfully. Nobody did anywhere near Creed. All right, so somebody's got a question from quiz number 1A. Let me see. Oh, and 5A. Okay. I don't know. You did fine on 1A. Raji, I don't understand what your question is. 1A is fine. It was your 1B that was missing labels. Oh, 5A. Okay, just 5A. Okay. All right, this is the one with the stem and leaf. And remember, everybody, stem and leaf is not complete until you make what? You make the stem and leaf. It's not finished until you show me
The key.
the key.
Keyword.
The key. And the key tells me how to read the whole thing. That's why it's kind of important. So how do you write the key for something? Well, if you have 7 line 6, and that means 76, it's exactly what you write. 7 line 6 means or equals 76. And then I know how to read the whole thing. Is that okay? So quite a few people forgot the key on their stem and leaf. Is that okay? You got it? Yes, okay. Anything else, guys, from the quiz, from homework, from anything? I have not built into Canvas fully yet. I did unlock Canvas's ability to just average your quiz grades. So you can take a look at that. It's just averaging your quiz grades. I also wanted to put in there, and I don't know, a range of if you have turned in no homework to if you turned in everything and it was all beautiful, right? I want to tell you what your grade range would be. Does that make sense? Like you would get somewhere between an 80 and an 88 if you had turned in nothing and if you turned in everything, right? So hopefully pretty soon I'll get that done. Oh, number 4. Let's just talk about the whole quiz. Let's see, number 4. Oh yeah. All right. So, all right, let me see. I think I could do this on the board better. Let me turn off my black hole. Black hole sun. No, I won't do that to you guys. Sorry. Hold on. Now it's in my head. Won't you come? All right. Let me see. What am I trying to say? Oh. What was I going to do? I forgot already. Let me see. Number 4. Oh yeah. All right. So now watch. If so here's people that like it doesn't even matter. People have Disney Plus, and here's people that have Hulu, right? So if you saw these numbers, it doesn't matter. If you saw those numbers up there, right? Can you tell me how many people had Disney Plus? How many people have Disney Plus?
21.
No.
2. If you're asking. Oh, altogether. My bad.
That's all right. How many people have Disney Plus? I don't care if they
Yeah.
have Hulu or not. Did I say anything about Hulu? Nope.
No.
How many people have Disney Plus?
40.
40. Is everybody with me? So if I tell you, if let's see, let's say there's another group of people, so I don't have to think of another thing, and I tell you that 38 have Disney Plus and Hulu. Where does that go?
In the middle.
In the middle. And then I tell you 50 people have Disney Plus. What is wrong if I do this?
No, we're supposed to subtract 38
Yes,
from them.
because how many people have Disney Plus according to my picture now?
88.
Oops, it's supposed to only be 50, so I've already got 38 there.
Yeah.
So then there must be 12 more. That makes 50 total. Do you guys understand? Remember I said you have to work from the inside out. That is why. Whatever the total amount for something, that has to be the total that's in that circle. And it automatically includes the part that's in the middle. So what if I do this, I have made people, which humans can do, but normally not that quickly, right? People. I can't do that. Does that make sense? Is that okay? Okay, so a few people made that mistake, but that's why we start from the inside, so we make sure that these numbers actually match what they're supposed to be total. All right, maybe. That's why a few of you guys would tell me, I think you have a typo because I have more people in my thing than I had people. Well, that's why. It wasn't a typo. You just created people, which is neat. All right. Anything else? Okay, so if there's nothing else, we're just gonna keep on going. So we are, oh, let me pull you guys over here. We're gonna get into the next section, which is all about dimensions. So we're gonna talk about area and volume. And I wanna warn you ahead of time. Well, I think this homework is one of the harder homework sections. And I'm not telling you that just to make you feel all freaky. Just be careful when you get into it. It's a little bit, there's a little bit more going on. So let's go through this step by step here. Let's see. So I think I already spoke about the pandering. I really hate books that pander. Oh, they like South Park. Just shut up. So we did a homework earlier this semester that talked about, it basically looked exactly like this problem. And at the time, they just asked you to count the squares. And they were trying to make the connection that area is measured in square units. Because to calculate area, I really am adding up the squares. So can somebody just take a minute and tell me how many total squares there are while I turn off my AC? Anybody? What's the quick way to do it, of course, instead of just sitting there counting them all?
4 times 5.
Yeah, so there's 4 this way, and there's 5 this way. So of course there's going to be 20 total. 20 what's the units?
Square inches?
Inch.
Square inches. So you could write that as like square inches like that, or more appropriately sort of would be like this. 20 square inches. And I really want you guys, I cannot cover an area using a length. I have to use little blocks to cover it up. And you could use different shapes to cover up an area. Are you guys, I really want you to understand. In fact, what is it here? That's what the point of this whole thing here is. Hold on. What thing, Jeff? I don't know. Hold on. This thing right here. Where are you? There it is. Let me take myself out of this equation here. All right. All right. First off, isn't this kind of trippy? You guys have seen this background of mine, right? And I think I already said this. Does anyone know who did this the fundamental artwork behind this? Anybody?
No.
No. Has anyone ever seen the movie Labyrinth with David Bowie? No. All right. Yeah, I love you guys.
Yes.
Yes, yes.
At the very end, all the trippy stairs, and he's walking around, and he's like, "Whoa!" Remember the
MC
trippy stairs at the end? That's
MC Escher.
MC Escher. There you go. So
Oh, yeah.
MC Escher actually loved mathematics, and what he did was he figured out, okay, I can cover a wall with squares. Does everybody agree? If you use squares, couldn't you completely cover a wall with a bunch of little squares? Isn't that possible?
Yes.
Yes.
I like that. Yes. What Escher did was he said, squares, okay, squares are freaking boring as shit. So why not use lizards instead? And do you see how the lizards completely cover that shape? Now, this is a little more interesting because it's 3D and it's circular, but he actually started off just covering like a big flat surface with lizards. Are you with me? And he also did angels and demons, and he also did birds and all this other stuff. Sorry. I really, stay with me, please stay with me. So I could, now here's the neat thing. We could measure area in lizards, but we don't. We decided to measure it in the simplest possible shape, little squares, right? And it actually makes the most sense, because if I use lizards, it wouldn't really work the same as counting 4 up and 5 over and multiplying. It would be a little bit more difficult. Anyway, I really, is everybody semi with me? So I really want this idea just to make complete sense. Why is area in square units? Because I cover an area with squares. That's the simplest shape I can use to cover an area. Okay. And of course, the shortcut way to count squares is just to multiply how many are in this dimension and how many are in this dimension and multiply those together. All right, so we know that already. We know the area is length times width. We know that formula, but that's where it comes from. So doesn't this look familiar? Do you guys remember that homework assignment a while back? It had basically this exact same picture. So how many cubes are here? How many little cubes are here? Anybody? Are you guys just counting them, or what are you guys doing? I don't know.
24.
All right, 24. How'd you get that?
Whoops. It's 48.
No. I didn't say you were wrong. Don't
You
change
did.
the answer.
You're doing length times width times the whatever the dimensions
Yeah.
are, right?
How many are on the bottom level? How many are on the bottom level? Wouldn't that be 4 times 2?
Mm-hmm.
And then how many levels do I have? 3.
You have 3.
So there's 3 levels, and each level has 4 times 2 bricks or cubes. So of course the formula for volume is length times width times height. And what would the units be? 24 what's?
Centimeters cubed.
Yes, good. Cubic centimeters or centimeters cubed. I love it. So we do actually count little cubes, right? Where are my people that whenever you move, you see the back of the truck as some kind of 3D Tetris game? Anybody? That's totally me. I see it as a big challenge. I'm like,
yeah.
Tetris the hell out of this moving truck. Let's do it.
You got to fit it
Chair
all
goes
in.
plop right in there. Thankfully, my stuff doesn't disappear as I complete a row, because that would suck. I don't know if anybody's with me. No, somebody is. All right. Blah, 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 blah. Okay. So this is stuff you guys know, but I saw some issues in that earlier section. So hopefully that makes more sense. Why area is square units, volume is cubic units. Oh, there's a chat. Yes, sir. Okay. All right, sure. Don't call me sir. All right. So let me clear all this away. So here's something. Let's do something more interesting. So some of you guys, I would hope that at least some of you would say to yourself, all right, math boy, sure, we use squares. What if I'm trying to measure the area of a circular area, math boy? What are your squares going to do for you now, math boy? You know, I'll keep calling him. You guys understand what I'm saying? Does anyone ever wondered that? Why are we using square units to measure circles? Has anyone ever stopped to think about that? You want me to show you where the
Is
formula
it
for
because
Huh?
the squares still, because they still work on the I don't know, never mind. It's hard to explain.
Yeah,
but
they work in the
my
middle, but
thought
then
process.
you need like fractional parts of them for the edges.
Yeah,
Okay.
but they
okay.
still make a square on the outside, right?
So here, you ready? This is so cool. All right, we're gonna do this. We're gonna do this. Someday I'm gonna do this with construction paper or something with my class. Construction paper, yeah, why not? So here. This is so cool. I still remember the first time I saw this, that somebody showed me this, and it was like in the last 15 years of my life, to be honest. So, which is kind of funny. All right, you have a circle. All right, pretend like that's a good circle. Does anyone know what this is? From the center to the outside.
What's the radius?
That's the
Radius.
We'll call him R. Now, a really good question is, so we have to start somewhere. Does anyone know what's the name for the perimeter of the circle? What's the better name for the perimeter?
Circumference.
Good. Of a circle is the circumference, right? It's circumference, and then he was knighted, so now it's circumference. Okay. Does anyone know what the formula is for circumference? So here's the cool thing. I'm going to build it for you. Stay with me. All right. If you take any circle in the universe, so I'm talking about this circle, I'm talking about that circle, I'm talking about cut the earth in half and, assume it's sort of circular. It's almost circular, not really. Our circle the size of our galaxy, right? So what they discovered, what several ancient civilizations discovered, was that if you take the diameter and you divide the circumference by it, so if you take the circumference of a circle, any circle, and you divide by its diameter, you always get the same number. No matter how big the circle is, no matter how small the circle is. Are you guys with me?
You're referring to pi, right?
Yeah, dude. So if we were in some ancient civilization and we were just kind of playing around with a circle, and how do you do this? You could have a length of string, you form it into a circle and you measure the diameter of it, and then you lay it out straight and you measure how long it is. So that would be the circumference. Is everybody with me? If I take a string and I form it into a circle and then I lay it flat, isn't the length of it equal to the circumference? Is that cool right there? Is that cool? Right? If I fold, is the length of it the circumference? Okay. So if I do that, no matter how long the string is, if I take the circumference divided by the diameter, I kept getting the same number. Now, if you were an ancient civilization and you kept getting the same number for that kind of thing, wouldn't that freak you out a little bit? No? Yes?
Yes.
So they thought it was divine. Several civilizations thought it was a divine thing. So of course it got its own symbol. And the symbol we gave it was pi, like Tricia said. All right. That was a long way to go for the formula. So now we know. Now watch this. So if I multiply diameter up, I get the circumference is pi times the diameter. How is the diameter? Oh gosh, so much math this morning. How is the diameter related to the radius?
the diameter is twice as long as the radius.
So diameter is 2 radii. So what does this formula become? If I put 2r here, it becomes 2 pi r. That's the circumference of a circle. That's the formula. That's actually the definition of pi, is what it really is. But then we use it as if it's a circumference of a circle. Okay. All right, let me stop for a second here. You guys doing okay out there? What is going on? Oh, I see what's going on. That was freaking me out. All right, now. Let me erase some of this stuff here. Make a little bit of room here. Let me put R there. And this is 2 pi r. This whole thing. So what is it? What is from here to there? What is that? If this is 2 pi r all the way around, what's halfway around? What is this?
1 by r.
1 pi r. All right, doesn't that make sense? It would be halfway. So of course it's half of 2 pi r. Stay with me, stay with me, stay with me, stay with me. Please stay with me. I can feel you guys going, oh my God. Now, here's where things get interesting. Let's cut this up into a bunch of little triangles. All right, here's where things get freakadelic. What I'm going to do is I'm going to cut it from the center out, but I'm not going to cut through the edge. So then I can open it up like this. I really want this to make sense. I can open it up like this, so then it's looking like this. Basically, I know I don't have the same number of triangles, but do you see I open it up and there that is. Does everybody see? So if I closed it back up, it would be this again. I know I don't have the same number of triangles, just give me a break. All right. How long is this? How long is this?
Half of the circumference.
So pi r. How tall is this? What is this roughly? How tall is it?
That's the radius.
Radius. And if I do the same thing to the bottom, open it up and shove it in there, doesn't it make, what shape would it make? Rectangle, I like it. And what would the area of this be? How long do I have to do that? All right, what's happening? What would the area of it? How do I find the area of a rectangle? I take its
Length times width.
good. So pi r times r, which I can write as pi. What's r times r? R squared. Does that look familiar, anybody? Anybody? Pi r squared, right? Have you heard of that formula before? Is it just me and Trisha today? Does everybody else went back to bed? Take this personally.
That's freaking crazy.
Thanks, Trisha. At least somebody's reacting. All right. Well, all right. I don't know what else to do for you guys. So one way we analyze areas of shapes we're not used to is to try to repackage the area into a shape that I know. This is kind of an extreme example. We took a circle and we made a rectangle out of it. But doesn't that make, if I have a certain area of material, couldn't I cut it and reorganize it to make it almost any shape I want to out of it? So why not make a shape that I know the formula for? It's the same area, right? I didn't cut anything out and throw it away. This whole circle is still here. So that's just a real quick example of why I can still use square units for something like a circle, because its area can be reorganized into a rectangle. The area of any shape could be reorganized into a rectangle. Okay. Well, shoot.
So then would that make cylinders cubed?
Yes, good. So you're kind of getting ahead of me. I needed
Sorry.
this. You're fine. You're fine. I need this formula for what we're going to do in a minute with cylinders. Kick ass. In fact, I might as well just do it right now. And again, let me make this plea, as I always do. You don't have to, but if anyone else can turn your camera on, that would be appreciated. I've got 2 cameras, and one of them has an empty room, so that doesn't make me feel too good. That's all right. You don't have to. You're fine. You're fine. Okay.
I'm here. My hair is just crazy.
Understood. Very much understood. All right, now watch. Let's talk about volume of a cylinder. This is going to be huge in this section. This is a huge part of this section. Volume of a cylinder. And by the way, oh, thank you. I see more people. Oh, you guys, thank you, guys. There's more people. Oh my God, you're helping my sanity. I've got like this much sanity left from last year. Do you understand? You guys understand. So anything, okay. I'm actually getting my vaccine, my first dose next Saturday. So I'm excited. We'll see how I feel the following Monday. All right. Side note. This is such a cool idea. Tell me again how to figure out the volume of a box. How to figure out the volume of a box?
Length times width times height.
Good. So what I do, let me say what you just said. I figure out the area of the bottom, right? I know this is not what you said, but I figure out the area of the bottom, and then I multiply by how much is stacked up, right? So I've got LW. How many LWs do I have stacked up? H of them. That's a weird way to look at it, I know, but that's basically, that. To be honest, that's the best way to look at that formula. Because now look what I can do. What do I have a bunch of stacked up to make this shape?
You have a bunch of circles.
I have a bunch of circles. What's the area of this one circle? We just did it, right? So here's the pi r squared. And let's say this is the height of the cylinder. So what's the volume of the cylinder then? It's going to be the base times the height. That is the actual formula for the volume of a cylinder. Let me make that pi a little bit better. Do you guys understand? So that's not such a mystery. That formula is not a mystery. There's a circle, and I have how many of them? H of them. So of course that's the formula for the volume. I'm just adding up how many circles I've got. Whoop-de-doo, right? And again, if radius is in feet, then that's feet squared times feet is of course feet cubed. So algebraically, it still comes out cubic units. But we know it's volume, so it's got to come out cubic somehow. All right, let me stop for a minute. How we all feeling out there? So I think I gave it enough emphasis. This is a very important formula. Here's another really important formula. And this one I can't, this one would require calculus to really show you where it comes from. I'm not going to teach you calculus today, right? But what about the volume of a sphere? So that formula is this. You ready? Here's the volume of a sphere. I can't really prove this to you. I'm sorry. 4/3 pi r cubed. That's the volume of a sphere. So if I have a sphere, give it a little, and I have a radius, Jeff, it's totally dependent on the radius. So it's 4/3 times pi times the radius cubed. crazy. Okay, maybe. I don't know. This might be, no, that's probably pushing it. I was gonna do, there is a little something I could do, but it still doesn't show you why it's 4/3. So I'm not gonna do it. It's a little freaky. All right. So let me ask you this. Can you figure out for me, please, what's the volume? So here's an example. Let's make this an example. Let's say I have a sphere and the radius is 7 centimeters. Can you take a minute? Figure out what the volume of that is. Don't write anything, don't say anything. Just figure it out and then sit on it for a minute. So what's the volume of this sphere? Sphere. Do you guys have a pi button? Can you see a pi button on your calculator or whatever calculator you're using? Do you see a pi button? If you have the correct kind of calculator, you should. If you have a scientific calculator or a TI calculator, it's there. Sorry, Tristan's trying to show something.
I was just trying to show where the pi button is.
On the
On
TI
mine.
calculator, it is above the caret symbol on the right-hand side of the calculator. Scientific calculator, it's, to be honest, it could be in a lot of different places. There's a lot of different scientific calculators. All right, so let me catch up to you guys. So this would be 4/3 times pi times 7 cubed. Is that 343? It's roughly 1360, is that right? I don't know. What'd you guys get? I could be really off, so don't worry if you're different from what I just said. It's probably more like 1380. I don't know. Holy shit, I was really far off. Oh well. 1436. I guess I'm not that far off, but still. So I got 1436.755. Did anybody else get that?
I did, Professor. I have a question though.
Yes.
Is it always going to be 4/3 times pi times r?
755. Yes, for a sphere,
Yeah.
that is the formula. If that formula changes, that means you don't have a sphere. Does that make sense?
Makes sense.
I like it. And I know it's weird, right? I would love it if anybody out there is like, where the shit does 4/3 come from? Is anyone thinking that at all? Or are you guys like, where is that?
Yeah,
And my advice to you is take calculus.
Is that the advice? Is that really advice? I don't know.
Yeah, sorry. No, there's actually some, well, like I said, there is a little weird thing I could do, but it still wouldn't explain why it's 4/3, but it would get us a little closer to this, but it's a little weird. All right. It doesn't show you where 4/3 comes from, so it's a little. One thing, let me see if I can, all right, let me do one thing with you guys here. Is anybody still having trouble with this? I mean, there's more to this, but that's basically what you get. What would the units be?
Centimeters.
That's not good.
Cubed.
Cubed. Good. Centimeters means it's just a string. Cubed makes it a volume. Yeah. All right. Now, let me do one thing with you that's interesting from a cylinder. All right. By the way, let me just do this. Any questions from this one? I'm going to erase this. The Death Star there. Go away, Death Star. So we can figure out the volume of the Death Star. So this is kind of cool. All right. What shape do I get if I stay with, this is kind of cool. If I start from the center of the circle down here and I carve it out like this. So I like carve out that middle section. So obviously what shape, and I'm gonna throw out the rest of the shit. I'm gonna carve this out. I'm gonna throw out the outside of it. What shape have I just made?
Cone.
A cone. What's really cool is when I shave off, and I really want you to understand this is all the way around. I'm shaving this off and it's just falling to the floor and I'm left with the cone. It's like I'm whittling some wood because I'm bored as hell. I lose 2/3 of this. So what's left is 1/3 of what was there to begin with. Did I just really prove it? No. Again, the proof would require some advanced mathematics, but it kind of makes sense. If I shave all the outside of this cone off, that's 2/3 of what was there before. So there's 1/3 left now. And if you think about it, this is kind of related to what I could do for a sphere. Couldn't I have a sphere that, let me see if I can do this. This is going to be a little freaky. See, this is gross. I can't really do this. Couldn't I have a sphere that does this, that lives inside of a cylinder? Anyway, that's going too far. I've gone too far. I'm sorry. I am going to fall now. I've gotten too close to the sun and my wings have melted. Anyway, so just there's a 1/3 at least showing up. And then you got to figure out, well, why is it 4/3? And anyway, all right. That's enough. Enough. So what do we got? What's going to be really important in this section? Volume of a cylinder and volume of a sphere. Those two, sphere, cylinder. Those are going to be huge in this section, just to warn you. Right? They really give a lot of problems with these two things. Okay, maybe. So let me ask you this. This is going to be a huge giveaway for this homework. But if I have a cylinder, let's say its radius is 5, and its height is 5 what, Jeff? 5 feet, and its height is 10 feet. And I throw into this a ball of radius 5 feet. Can you do me a favor? What's the volume of the cylinder? And what's the volume of the ball? Do those two things for me. What's the volume of the cylinder? And what's the volume of the ball? You've got both formulas here. Go for it. The time's okay. We got plenty of time.
What was the radius of the cylinder again?
5.
5. Okay, I couldn't see.
Same as the ball. Yeah, sorry. Maybe that's better. I don't know. Is that better? A little bit. Let's see. So, volume of the cylinder is pi times radius squared times height. So now I just got to throw that in the old calculator, right? Volume of the sphere, the ball, is going to be 4/3 pi times r cubed. What do you guys get? Anybody get the volume of the cylinder?
I almost got it, then I screwed it up on the calculator.
Oh shit.
Would it
Is
be-
that it's 785? I could be wrong.
that's right.
Got it. 785.398. So if you make it 4,
Yeah.
what are the units?
Feet cubed.
Good. Be really careful. I can't remember the section, but obviously these have got to be the same units, right? Remember we had problems earlier where one side was in inches and the other side were feet or something stupid. So I can't remember if they do that to us again here, but be careful. So that's the volume of the cylinder. Has anyone gotten the volume of the sphere?
523.6 feet.
523 point, 6, we could say, cubic feet. So how much empty space, if I throw the ball in the cylinder, how much empty space is around that ball? How much empty space? The empty space, right? Because it's a ball, so it's not gonna conform to this. It's not a cat, and cats are liquid. So if you throw them into a cylinder, they take the shape of the. It's a ball, so there's going to be outside. How do you figure out how much empty space there is? This empty space. How do you figure that out?
Figure out the cylinder and subtract.
Yeah. Here's how much total empty space there was. I threw this ball in. So how much empty space is there is going to be this minus this. So volume of the cylinder minus volume of the ball. So if I subtract those two, what do you guys get?
261.
261.8.
You can do it, Jeff. There we go. So you got this much empty space around the ball. I like it. Has anyone ever seen that video? I need to find this video because it's really cool. And they have this container, I think it's cylinder, and they put these big balls in here. They throw a bunch of big old balls in there, big rubber ball, whatever. And then they're like, well, it looks like it's full, right? And then they throw tinier balls in there. And they of course, and then they throw grains of sand in there to fill all the empty space around all the different balls. You with me? Okay. Yes. All right. Anyway, so I got to find the video because it's kind of cool. So what we just did here will help you tremendously in the homework. Tremendously. All right. So let's get back in the book so I don't forget anything. Let's see. Doobie. All right. Let me see if I can do this here. All right, here we go. So let's see, we left off about right here. Let me see. Oh, okay. Well, this is not bad. That's pretty simple, right? If you wanted to find the area of this painting, you just multiply length and width. Here's the cylinder. So take a minute, do number 8. Figure out the volume of this cylinder, and they tell you to do it to the nearest 10th. Oof. What happened? Oh, there you are. Dooba, oh, Scoob. By the way, guys, do any of you have a laptop that has not enough USB connections? Do you know what I mean? Like every time I wanted to plug in the thing that I used to draw on the screen, I had to unplug my speaker, and that was stupid. So I finally invested in a little USB hub. So you connect it and it instantly gives you 4 more got to be careful about the power consumption on that, but it's anyway, just I'm surprised it took me this long to realize I could get that stupid thing. And I'm like, why didn't I get that thing years ago? Good Lord. So just in case, maybe I'm showing, and you're like, well, of course I got a USB hub, old man. All right, whatever, shut up. What are you guys getting for number 8? So we got pi times, why do they have, oh, that's kind of dumb. Look what they did. So why do they have 4 spots? Because they want you to write the radius twice, I guess. But we're better than that. We don't need this stupid thing. We just put 5 squared. So what do you guys get? Anybody get that answer?
706.858.
Uh-oh.
Yeah.
706 point what? Somebody else got it? There
Oh,
it is.
0.9.
There you go. And then units.
Meters cubed.
Coolness. All right. So you know, I'm gonna be kind of an asshole with. If you leave the units off, I'm gonna say unicorns. I'm gonna say, and with a question mark. I'm gonna be just a dork. So don't force my dork hand on this. Just don't forget the units when you give me the answers. Okay. All right, so let's see. Let me clear that away. Nothing too amazing happens here. These are kind of silly. This is just, can you use equations correctly? Hey, let's do this. Try to do number 12 in your calculator. Throw it into your calculator. Let's see what we get.
You wanted number 12, right?
Number 12, yeah.
Okay.
So who's got that?
Is it 35.34?
Yeah. 35.3.
Oh, yeah. My bad.
And then what? How's everybody doing? Did anybody not get that number? Are you guys okay out there?
Yes.
Okay.
I keep getting an error.
Interesting. Let me think. What could you possibly?
Okay. I got something different.
What'd you get?
I got 30.4 instead of 35.3.
All right. Let me think. What would you have done differently?
Can I show you?
Sure. All right.
Okay.
Wait. Hold on. Let me stop sharing. Hold on. Just hold it right there. Where are you? Dadgummit. Hold on.
I'm showing you my calculator right now.
There it
I don't
is.
know if you can see it.
4. All right. Hold it right there. Oh, do you see how the first one says 1.3 and it should say 1.5? Okay. That's a simple one.
Huh?
The first little dude that's to the third power, it should be 1.5 and you have 1.3.
Oh, okay.
Yeah, so that's it. That's an easy problem. So you can fix that real easy. Thank you.
Oh,
I don't
God,
mean to make you feel
I
bad. Hopefully you
cannot
don't
see
feel bad.
my calculator.
It's easy. You got 5s and 3s and shit running around. Who else didn't quite? Oh, Trisha, are you getting 706.9? Is that what you're getting?
No, I was the one that got an error.
Oh, okay. What exactly is the error? What does it say?
It just says error.
No, it can't just say error. Oh, wait. Oh, you've got a scientific calculator. Because you have a TI, it gives you a little more information, but I guess you have a scientific calculator. Let's see. Okay, let me see. Let me open up my scientific calculator. Here we go. All right, so not everybody's, in fact, nobody's got one that's set up this way, basically, but I can see my pi button. So if I do 4 divided by 3 times pi, I already forgot there it is. It's right there, Jeff. Times 1.5 cubed. Where's my to the button? That makes that much plus pi times 1.5 squared times 3. Yeah, there's not, I'm trying to figure out what part of this would make you get an error. I don't know. All right. I'm not sure what would make it come out to be an error, Trisha. I'm sorry.
Probably just an operator error.
Well, to be blunt, yes, but I don't know exactly what it is. Are you putting parentheses in? Don't. You probably just have the parentheses in the wrong place or something weird. Parentheses could lead to an error, I think. You don't need them. So try to put it in there again without parentheses.
Okay.
Okay. Just use time symbol. Yeah. Sabrina, you good? Okay. All right.
I'm good.
All right. So let's see what else this thing has in store for us. Close is my calculator closed? Yes. All right. What is all this crap? Sorry. All right. Blah, 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 blah. Good Lord. What is going on? All right. Let's read this together, class. Let's see what they're trying to tell us. Today, knowledge is ubiquitous. Ooh. Constantly changing, growing exponentially. Knowledge is free. It's like air. It's like water. It's become a commodity. There's no competitive advantage today in knowing more than the person next to you. The world doesn't care what you know. What the world cares about is what you can do with what you know. Interesting. What do you guys think about that? Any first reactions to that? Why is it here? I have no idea, but we're going to look at it real quick.
Is it just trying to say that it doesn't matter how much, just what you do with what you know in your life? I don't know. It really
Yeah.
seems kind of like a little too thoughty and too like
Yeah,
wordy
it's like
for
somebody that likes to.
To me, it's talking about like using your knowledge and like using wisdom to like to spread ideas to other people, so then they can learn from you, because you can definitely learn from like your friends. You can learn from
Okay.
like pretty much anybody. So
Yeah, this last
that's what it
sentence
talks
could
about.
mean, what do you do with what you know? You could teach other people. I like that. But it's more like everybody knows everything to a certain degree, right? Not really in their head, but don't we all have a device where we can look anything up? But we can find erroneous information at least as easily as we find the correct information, right? As evidenced by so much nowadays. But to me, the thing that I don't quite like about this is you still need to know things in your own head. But I do agree with the part, everybody knows everything to a degree. You can look it up on Google. What's important is, do you understand what that means? Do you know how to use that information? Okay, we don't need to get this deep. Why is that there? I'm not really sure. Yeah. So that's all. This should be semi-easy stuff here. Right? What do you get right here for part B? You don't need any calculator for that. What do you get for part B? Anybody?
Would that be 30 feet cubed?
Yeah, 30 feet cubed. 6 times 5 is 30. Feet squared times feet is feet cubed. I like it. Just the same way, what do you get for part D?
30x cubed.
30x cubed, yeah. So the feet are collected the same way variables are collected. I have 3 x's here, 1, 2, 3. So of course it's cube x. I got 2 feet and another foot multiplying. So of course it's cubic feet. It's just keeping track of how many of them I've got multiplying. Let's see, blah, who cares? Right, perimeter is dumb you don't want to know any perimeter formulas. It's kind of silly because perimeter is just add up all the sides. I don't need any formulas because that idea never changes. The only formula I need is for a circle who technically has no sides, or it's got one side, or it's got infinite sides. It depends on the way you want to look at it, and that could really trip you up. That's the one shape I need a perimeter formula for. Every other shape that has linear sides, I don't need a formula for the perimeter. I just add up all the sides. Blah, 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 blah. Who cares? Blah, 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 blah. Oh, why is the area, let's talk about this for a second. What's the formula for the area of a triangle? So let me set up a triangle. What's the formula for the area of a triangle? Does anyone know?
Is it length times width times 1/2?
Yes, well, sort of. So it's base times height times 1/2. And can anyone tell me what the relationship between the base and the height has to be? Why didn't I use this as the height? Or why didn't I use this as the height? Or this is the height? Why did I have to use this? Does anyone know? How do the base and the height have to be related to each other?
Because one is horizontal, one is vertical.
So they have to be 90 degrees. I like it, right? They have to be 90 degrees to each other. So when I say height, I mean, it has to be, do you guys know this word perpendicular? Perpendicular just means makes a right angle. Okay. So watch this. Here's why this is true. If I had a rectangle that had side H and B, what would its area be? If this was H and this is B, what's the area? How do you find the area of a rectangle?
2 times H and B. H times B.
Just H times B, yeah. Right? I was going to write BH, but then I have to be careful how I say that. So what do you think about this? What do you think about, does anyone know what shape this is? Pretend like I'm drawing well. So this is parallel to this. So these sides are parallel and these sides are parallel. I'm basically giving it away with what I just said. Anyone know what shape this is?
Parallelogram?
That's right. A parallelogram. That's right. Do you notice how this side is not perpendicular to this side, correct? Stay with me now. This is kind of cool. I know this is getting really dry. So I must still use the actual height times the base, but I want you to notice something. Remember, we took a freaking circle and repackaged it into a rectangle. Watch what happens if I take this, let me take this triangular section, let me cut it off and let me move it over here. Doesn't it just become this? Yes? No? You're insane, Jeff?
Yes.
Yes. So now watch. Here's a parallelogram. So now you understand why the area of a parallelogram is the height times the base. That's definitely true. And isn't any triangle half, oh look, it's my triangle, half of a parallelogram. So of course the area of any triangle will be 1/2 of the related parallelogram. Does that make sense? That's why the formula for triangle is that, because it is exactly half of the parallelogram it comes from. All right, that's not as exciting as the circle one, but still that's kind of neat. I don't know if anybody's ever seen that explanation before. All right. Sorry, I was going to make a song about this 1/2 height times base, half height base. Anyway, sorry. No, is that song too old now? All about the base? No? Okay, I'll stop. All right, let me clear this away. All right, so that's just a little, so just look at this. I want you to look at the homework. This is the first homework section, I think, that is harder than the examples that led up to it. So I just want you to be ready for that when you go into this. I'm not saying that it's hard. I'm saying it's harder than the examples. There's a whole bunch of, do you see how I try to get you ready for this? There's a cylinder with 3 balls in it, and then I'm going to ask you how much empty space. So you got to take the volume of the balls and subtract it from the cylinder. So that's basically what this is doing. Do you guys see that? Isn't this the volume of the cylinder? Pi r squared h minus 3 tennis balls. So that's doing the same thing we did earlier, finding the volume of the empty space once you put the balls in there. All right. Okay, and then they go from there. And then they basically do the whole problem again, but this time with badminton balls. Not badminton, racquetball. Badminton's got the weird shuttlecock. Anyway, let's not talk about the rules of badminton. All right, I think that's enough for today. I should probably stop there. Let me know if you need to hang out afterwards if you have any questions. Otherwise, you are free to go.
Thank
Have
you.
a good day.
See you guys.
Thank you.
Thank you, Professor.
Take care.
Quick, well, it's not even a question. So this, I've tried to download my book and re-download and download, and I just can't, like, I'm not getting the homework. And so I'm gonna try and contact Amazon. I don't know if it'll do anything, but I think I may have to just order a paperback book or a hardcover, and get it that way, because I'm not able to see anything, which is frustrating.
So here, you know, what you can do for this homework is you can come to this video up on YouTube and you can see the.
Yeah, that's what I've been doing.
Okay.
Just to make sure that I am getting all the problems in. So yeah. Okay. So my 2.1, I submitted, but I had a feeling it was just the application, and I was like, it's the only thing that's showing on my book. So
yeah, here's the applications on page 163. None of this showed up at all?
None of so I have the chart. So I have the names, and I was like, okay, so I'm missing questions. No question is showing up. See, in my previous sections 1, I was having the questions, but not the chart.
Oh man.
So it's really.
So they thought, well, this will make up for that.
Yeah. So I'm having a lot of difficulty trying to like piece together everything. So I'm like, okay, I hope I get all the questions. Okay. And yeah, so I figured I would just go back in the lectures and do it that way and just re-listen to the lectures. I can see the questions.
Yeah, I guess technically what I'm doing right now is kind of illegal also. I'm not supposed to transmit copyrighted material, but
yeah.
Oh well, too bad.
I'm gonna try and figure it out, but yeah, I'm gonna see. Hopefully I get something.
So I got those up there so you can go watch the video. Okay.
Oh, perfect. Thank you so much.
Sure. Oh,
question. I do have another question.
Yes.
And I think I already know the answer to this.
Cool.
The quiz, we're able to resubmit if we got a higher score.
If you got what?
Because I got a higher score this time, but you can still resubmit one more time no matter the score.
Oh, no. You can only correct everything once. So
Once, right? Yeah. That's
So
why
if
I
you
haven't.
haven't corrected it yet, you can correct it. It doesn't matter if you get a 99, you can still
can
correct
still-
what you missed and get that 1 point back. Yeah.
Okay, got it. Okay, perfect. That's it. All right, thank you.
You're welcome. Adeline, you're good? You all right out there? I'm gonna head out. Okay. Bye.